Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss properties of hydrogen gas, also called dihydrogen gas. First I will discuss physical properties. Actually last class I have discussed preparation of hydrogen gas that I have discussed in very details. Now I am going to discuss physical properties of hydrogen gas, also known as dihydrogen. Dihydrogen is a colorless, odorless, tasteless, combustible gas. It is lighter than air and insoluble in water. In other physical properties, already I have sent one in last class I have sent one chart. Okay, that also some properties are given, physical properties. Then hydrogen gas, actually it is a odorless, no odor, no smell. Colorless means no color. Tasteless, no taste. Combustible gas means it can burn. And it is lighter than air. It is lighter than air. It is the lightest gas, you can tell. It is lighter than air and is insoluble in water. Now come to the chemical properties. Chemical properties of hydrogen gas. The chemical behavior of hydrogen gas is determined to a large extent by bond dissociation enthalpy. Or you can tell bond dissociation energy. The HH bond dissociation enthalpy is the highest for a single bond between two atoms of any element. In comparison to others, HH bond dissociation enthalpy is the highest for a single bond between two atoms of any element. What inference would we will draw from this fact? If this dissociation energy is highest, what conclusion we will draw from this? It is because of the factor that the dissociation of dihydrogen into its atom is only 0.081%, roughly 0.081%, means very, very less. And that also this dissociation will take place at 2000 Kelvin, because bond is strong, very strong. Hence it requires a very high temperature, around 2000 Kelvin. At this high temperature also, this is very less. This will dissociate. That dissociation will take place very less, 0.081%. And this may increase further. Dissociation may increase up to 95.5%. Dissociation may increase up to 95.5% at 5000 Kelvin. Means as the temperature will increase, dissociation will increase. Also, it is a relative inert at room temperature. This hydrogen gas is a relatively inert gas inert relatively at room temperature due to the high HH bond energy. Thus we can tell the atomic hydrogen is product at high temperature in an electric arc or under ultraviolet radiation. Means you can produce it. It is produced only at very high, means I am talking about the atomic hydrogen, only one H can be produced at a high temperature in an electric arc or under ultraviolet radiation. Since its orbital is incomplete with 1s1 electronic configuration, it does not combine with almost all the this I am talking about, again you listen. Since its orbital is incomplete with 1s1, means it has only one electron in s orbital. Its electronic configuration is 1s1. Okay. It does combine with almost all the elements. Hydrogen atom, because it has only one electron, S1. That's why it combines with almost all the elements. It accomplishes reaction by how it will accomplish reaction. It will do reaction. Then first, loss of the only electron, means by losing one electron it can react. Loss of the only electron to give H plus. After losing the one electron, it will form H plus. Second, by gaining an electron to form H minus, H1 minus. It can also react by gaining one electron, because only one electron is there. It wants two electrons. Hence, after taking the electron, it forms a hydride ion, H1 minus. And third, by sharing electronic, or you can say by sharing electrons, okay, by sharing electrons to form a single covalent bond, means by forming covalent bond it can react. Then it can react in three ways I told you. Okay. And now this I am telling other reaction. The chemistry of hydrogen gas can be actually we can discuss by the many way. Okay. Then now I am telling you example of the this things reaction. Example of the reaction. First reaction I am telling you, reaction with halogens. Reaction with halogens. Halogen means fluorine, chlorine, bromine, iodine, statine, all are the member of halogen. Then this is generally it is halogen is presented by X, capital X. Okay. Then now I told you it reacts with halogens. Halogens like just like a fluorine F2, you can write X2 that represent halogen. Okay, in general representation X2. Then H2 plus X2, H2 plus X2, both are gas. In a gaseous form, halogen will react with hydrogen. Then H2 plus X2, very simple reaction. It will form 2HX, 2HX like 2HF, 2HI, 2Br, 2I, like that way. Astatine is a radioactive element. Last member of halogen is radioactive. Okay. Then here H2 plus X2, X2, that is a 2HX. Okay, where X is equal to fluorine, chlorine, bromine, iodine. Okay, while the reaction with fluorine occurs even in the dark, it will react with halogen, but for the this with fluorine, it can react in the dark also. With iodine, it requires a catalyst. As it will go down, fluorine, chlorine, bromine, iodine, then that reaction very fast with fluorine, and it can take place even in dark also. Generally, heat is light is required generally, but due to very high affinity of this fluorine, it can react in dark also with hydrogen. And iodine, for the reaction with iodine, it requires catalyst. Suitable catalyst is required. Okay. Now I am talking about the other reaction, other example. Reaction with oxygen. Reaction with dioxygen means O2. Di means 2. 2O means O2. Then reaction with dioxygen means dioxide means oxygen. Then 2H2 plus O2. All reaction is going on in gaseous state. Then 2H2 plus O2, it will react, and it will form water. It will form water, 2H2O, liquid. And heat of formation, it will release the heat during the reaction. It will release the heat, exothermic reaction, that is minus 285.9 kilojoule per mole. This reaction is exothermic reaction. It releases delta H value is minus 285.9 kilojoule per mole. This amount of heat it releases. Okay. Now other example I am telling you. Then third example, here also actually 2H2 plus O2, here also catalyst is required. Okay. Now maybe platinum. Platinum generally it is used, platinum or nickel. If suppose catalyst is not available, suppose, then you have to heat it. You will have to heat if catalyst you are not using. That is the substitute of catalyst in any reaction. If catalyst you are not getting, then a strong heat is required. Okay, now third example I am telling with reaction with nitrogen, N2, dinitrogen, N2. Okay. Then now here also already this reaction I have discussed. You might be knowing also hydrogen plus nitrogen means 3H2 plus N2. It is very common reaction. All are common, only what I have discussed. Then this hydrogen plus nitrogen, this is a common reaction. It forms ammonia. Many times I have discussed, but this reaction takes place, condition is there that catalyst is required, that is the iron catalyst, and temperature, high temperature 673 K, and pressure is also Actually, temperature you can tell moderate. Okay, this 673 Kelvin, and atmospheric pressure is 200 atmospheric pressure. What is available atmospheric pressure? That is a 1 atm. 1 atmospheric pressure available anytime 24 hours. What we face pressure, that is the 1 atmospheric pressure. But now here it is required 200 atmospheric pressure. Then what will be the product? Might be knowing, that is the, you will get ammonia, NH3 gas. Okay, means balanced equation 3H2 plus N2. You will get 2NH3. Here, objective type question, they are asking what temperature is required. Temperature, pressure and catalyst. 3 things they will ask. And temperature is 673 Kelvin. Pressure is 200 atmospheric pressure. And catalyst is iron. And product, what it will form? Then ammonia, 2NH3. And it is also exothermic reaction. Delta H value is minus 92.6 kilojoule per mole. Okay. This is the, then I have told this is the method, and also this what I discussed reaction, this is the method for manufacture of ammonia by the Haber process. Haber process, in this way this ammonia is produced. And why the importance has been given for ammonia? Because it is used in the manufacture of fertilizer. Okay, fertilizer, in fertilizer it is used, ammonium, particularly nitrogenous fertilizer or ammonium phosphate. Now next reaction I am telling you, reaction with metals. With many metals, hydrogen combines at high temperature to yield the, you can say, or to give the product. Why high temperature? I think just now I have discussed today only that for the reaction hydrogen bond, without breaking the hydrogen bond, hydrogen can't react, because HH bond is very strong. I told you that very high temperature only bond will break. It will come into the atomic form. It will form ion at high temperature. Otherwise bond will not break. That's why high temperature is required. Then here with metal H2 plus 2M, M means metal, general, 2M, it will form 2MH, and this is called hydride. Corresponding hydride it will form. H2 plus 2M means it will form 2MH, solid. Here hydrogen gas, hydrogen in the form of gaseous state, and metal is in the form of also gaseous form, means we have heated strongly, it turned to the gaseous state, and then it reacted and formed metal hydride, 2MH, okay, solid, where M is an alkali metal. Then if suppose sodium is there, then it will form sodium hydride. If potassium is there, it will form potassium hydride. If calcium is there, it will form calcium hydride. Magnesium is there, it will form magnesium hydride. Okay, it can react with alkali and alkaline metal also. Okay, with a group 2 it will form like CaS2, BaS2, like that way. And alkali metal, sodium, lithium, sodium, potassium is there, then lithium hydride, potassium hydride, sodium hydride, like that way. Now next reaction I am talking about reaction with metals. Reaction with metals already I have told you. Now reaction with metal ions and metal oxides. Now I told you about the only with metal. Now metal ions and metal oxides. Okay. Here what will happen, that hydrogen reduces some metal ions in aqueous solution and oxidize and oxides of metals. For both, it can react with the metal ions and with oxides of metal also. Okay, and it will form, as for example, I am talking about hydrogen plus palladium in solution PD. Okay, PD ion. Generally, it will be in the palladium chloride. Okay, then H2 plus PD, it will form PD ion will be converted to the metal, cause hydrogen will give the electron. Hydrogen will actually give the electron, 2 electron, and it will be this PD2 plus. Now it convert to PD, means by getting 2 electron, now it converted to palladium metal, and itself hydrogen itself now converted to the 2H plus in solution. In solution it will convert into 2H plus. Okay, means now this hydrogen reduces the metal ion. Reduces the metal ion means it has given electron to metal ion like palladium. Okay, now I am giving example for, you can say, oxide. Okay, then any oxide you can tell, like Na2O. Sodium oxide is there, Na2O, sodium oxide, and H2 is there. Hydrogen plus Na2O, it is metal oxide, then it will form 2Na. It will form 2Na, Na2O, 2 sodium is there. Then Na2O, 1 oxygen and 2 sodium. Then hydrogen will react and it will form H2O plus 2 sodium. Here same things. Here again hydrogen has given 2 electron. 2 electron has given, and metal was sodium by 2 sodium was there, Na plus. If in a metal oxide, what will happen? 2Na is there, Na2O. Then oxygen has 2 negative charge and each sodium has 1 positive. Then this 2 positive, 2Na positive. Then this will react. This Na plus, they have taken the electron, 1 electron from hydrogen they have given. Then now they converted and formed 2Na, and H2 became 2H plus, 2 hydrogen ion it formed, proton, H plus. Then now it will react with the oxygen which has 2 minus. Then now 2 plus and 2 minus neutral, hence it is formed H2O. Then this I have told how it is reacting. Okay, in general you can write, in general way reaction can be written as YH2 plus MXOYE, MX. You don't know what is the value of X and Y because you don't know which metal you are using. Generally less active than iron. Here metal means a strong metal, it will not react. It will react less active less active than iron. Okay, active metal, it will not react with very active metal. Less active, it should be less active than iron. Then general way I am telling you, general reaction, YH2, Y is the coefficient, you don't know, plus MXOY, OY. Then X also we don't know value, Y value also we don't know, but it will give product XM. Mx was there, MXOY, then it will give XM metal, solid, and YH2O. Okay, this I told in general. Now next reaction I am telling you, reaction with organic compounds. It actually, hydrogen reacts with many compound. Everywhere you will find hydrogen, particularly all organic compound. You know that ethane, methane, propane, anything. You will find any type of carbohydrate is a different type, glucose, fructose, sucrose. Everywhere hydrogen is there. Okay, even I told you protein also, fat also. Then hydrogen reacts with you can say organic compound. Okay, and it will form new compound. Okay, it means hydrogen reacts with many organic compounds in the presence of catalyst, suitable catalyst, to give useful hydrogenated products of commercial importance. And actually it will form a product that will have importance, commercial importance. You can do marketing. As for example, hydrogenation of vegetable oil. Oil is there. Vegetable oil is there. Then you can hydrogenation can be done of this vegetable oils using nickel as catalyst, and it will give edible fat. Means oil will convert into fat. Okay, and it's an example, that is Banaspati ghee. Banaspati ghee, that is example. Other example is margarine and Banaspati ghee. Then this is very, very important reaction, hydrogenation of vegetable oils using nickel as catalyst. Okay, and it gives edible fats. Second example I am telling you, hydroformylation of olefins. Olefin means double bond, carbon double bond, like that ethene, ene, ethene. Then you can you can do hydroformylation of olefin. It yields, means it gives aldehyde, which further undergo reduction to give alcohol. This is very, very important reaction. Means H2 plus carbon monoxide, H2 plus CO, carbon monoxide, plus RCH double bond CH2, this organic compound. RCH double bond CH2. Actually, ethene will be CH2 in the middle double bond. CH2 in the middle double bond. I will discuss in details when I will start organic chemistry. But here CH2, then between the CH2 double bond is there. It is actually unsaturated. If double bond is there, triple bond is there, then that is called unsaturated. And when there is a single bond, then it is called saturated. Actually, what I have discussed now, hydrogenation of vegetable oils. Then oils will be generally unsaturated, and means it may have a double bond, triple bond. Then when hydrogenation will be done, then this double bond or triple bond will become single bond. Bond will break. When one bond will break, then two hydrogen can join, because two electrons it will give. Each carbon will take one electron, because it was made due to the sharing of electron, and that bond broken. One bond broken means if one bond will break, then two electron was involved, then each carbon will take one electron. And now hydrogen H2, their bond also will break, then they have one electron, they will have one electron H2, HH, between HH two bond is there, two electron is there, then each will take a single electron. Then now hydrogen has single electron and carbon has single electron, they will make bond, CH bond. Same way other carbon have one electron and hydrogen has one electron, again they will share and they will make a bond. Then double bond became single bond, means now it became saturated. Single bond means saturated. Now further it will actually, if one you can break it, but generally when single bond is there, only then carbon single bond, then it is called saturated. Then here in second, I am telling you, in this reaction H2 plus CO means carbon monoxide plus RCH2 double bond CH2. Here what is happening, CH2 double bond is there, but here RCH is there, RCH double bond CH2, other carbon two hydrogen is there, but the first carbon one R is there, that is called alkyl group. R means alkyl group, maybe CH3, maybe C2H5. C2H5 is called ethyl group, CH3 is called methyl group. Then so many groups are there, methyl group, ethyl group, propyl group, butyl group. Then it differs in number of carbon and number of hydrogen. CH3, one carbon, three hydrogen, CH3, that is the methyl group. C2H5, that is the ethyl group. Like that way, C3H7, propyl group. Okay, I will tell in details when I will start organic chemistry. Now, then here RCH double bond CH2. Then in the place of one hydrogen R has come. Another carbon has CH2, two hydrogen, no problem. But first carbon has one hydrogen, and in the place of other hydrogen R is there, alkyl group. Then RCH double bond CH2. Then now you have three reactant, hydrogen plus carbon monoxide means CO plus RCH double bond CH2. Then here you can see hydrogen again, bond will break, HH bond will break, and keep in mind, if bond will break, then each hydrogen will have one electron. Then now here what will happen, double bond complete, this can say this CO plus RCH double bond is there, then that double bond will convert into the single bond, and these two hydrogen will join. And also carbon monoxide is there, then actually this carbon monoxide bond will also break. COO, CO bond, carbon monoxide, it is very reactive. Then here CO bond, double bond is there, means double bond means two electron oxygen has given, two electron carbon has given. Okay, then in one bond 2 electrons is required, then double bond 4 electrons. It is shared, then 50-50. Then carbon has given 2 electron, oxygen has given 2 electron. Then now it became 4 electron. This is very, very reactive, and each has a lone pair of electron. Okay, because carbon has 4 valency. Carbon has 4 valency. Then now this carbon monoxide bond also one bond will break. Out of 2, one bond will break, and it will give a very important product, that is the RCH2CH2CHO aldehyde group. CHO is the aldehyde group. COO group, that is called ketone group, ketonic group. Okay, ketonic. And CHO group is called aldehyde group. Okay, CHO always will be separate, but now it is joined. CHO means COO, and one H is there with carbon, and one electron is there remaining. Total carbon has 4 valency, means each has 4 electron to react. Then it already reacted with 2 oxygen, CO. CO was there, na? That way it can tell that bond also breaks, COO bond. But this is the final product I am telling you. But in aldehyde I am talking the situation, CHO group, COO bond will be there, and one hydrogen attached, and one electron is remaining. That is shown by one half bond, just only one line you will show. If you will not react, then it will be CHO, and one little line, small line will be there, means one electron is there. It has not reacted with anybody, anything. But here it is reacted, it formed aldehyde. And which aldehyde? Then RCH2CH2CHO. Okay, R value is not given, hence you can tell this is the, you can say, alkyl aldehyde. Okay, and after that what will happen? This aldehyde RCH2CH2CHO, again if more hydrogen is there in second step, again this aldehyde will react. This aldehyde will react, means H2 plus this aldehyde, means RCH2CH2CHO. It will react, and it will form, again I told you, double bond of oxygen, carbon oxygen, that will break. Now it will become single electron, a single bond of oxygen, because now it will form alcohol. Alcohol means OH group. OH group is called alcoholic group. Then here actually alcoholic group means one bond, O and H, one bond will be there, single bond. Okay, and one line will be there, a small line, that means one electron is there to react. Okay, and oxygen has 2 pair of electron remaining, lone pair of electron in OH. But OH means here OH and one minus will be there, means that is representing that it has 1 electron. Then now in this situation, this aldehyde CHO group now converted into OH group, alcoholic group, and it form RCH2CH2, again one more CH2, means 3 carbon. 3 carbon was there at that time, RCH2CH2CHO. Now this CHO, last group aldehyde was there, in that now one more carbon has come. This hydrogen broken, one it will one H2 will give 2 hydrogen. Then one hydrogen came with carbon, and other hydrogen came with oxygen. That's why CHO now converted CHO, now it became CH2 and OH. One hydrogen came with carbon and other hydrogen came with oxygen. because double bond of oxygen broken. Okay, then now 1, 2, 3. 3 carbon they have hydrogen. Okay, then RCH2, CH2, CH2. 3 times CH2, 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 and in the end it is a OH group attached. That's why it is called, this compound is called alcohol. If CH3OH is there, it is called methyl alcohol. If 2 carbon is there, C2H5OH, then it is called ethyl. If 3 carbon is there, then it will be called propyl alcohol, butyl alcohol, pentyl alcohol, like that way. I will tell you in details in the when I will start organic chemistry. Okay. Now I am going to tell some application, usage of hydrogen gas. Usage of hydrogen gas. Then it has many use actually. Hydrogen has many application, usage. Then one by one I am telling you. First, the largest single use of dihydrogen is in the synthesis of ammonia. Ammonia gas, when we make ammonia gas, there you know that N2 plus 3H2 hydrogen ammonia gas is formed. Then in the synthesis of ammonia gas, it is used. And this ammonia gas is used in the manufacture of nitric acid and nitrogenous fertilizer. Okay. This is the first use. Second use, dihydrogen is used in the manufacture of vanaspati ghee. Already told you, vanaspati ghee, that is a fat, oil is converted into fat, vanaspati fat, by the hydrogenation of polysaturated vegetables. By the hydrogenation of polyunsaturated vegetable oils like soybean, cotton seeds, etc. Okay, these are unsaturated. Now it became saturated by hydrogenation. Okay. Third use, it is used in the manufacture of bulk organic chemicals. Many organic chemicals are formed. Many, particularly methanol. Then carbon monoxide plus 2H2. Already I will discuss the reaction, very common reaction. CO plus 2H2, both are gaseous state, and in the presence of cobalt catalyst. Actually all I can say this D block elements, all D block elements, almost all, that is function as a catalyst in general. All D block elements, metal, function as a catalyst. Okay. What is actually its main, what is the main cause why it is used as a catalyst? D block elements, transition elements, because their d orbitals are vacant. D orbitals are vacant. Then there you can say this reaction time, temporarily reactant will, actually it gives a platform. This metal will give just like a platform. Reactant, generally this d orbital catalyst will be in the powdered form. Then this reactant will come there, and both reactant will meet there on the catalyst, and there this change temporarily they will make a bond with this catalyst, very weak bond. Temporarily they will make bond with catalyst, and slowly that bond will break, and both reactant will make bond, and when both you can say reactant will make bond, then this bond will be broken. Bond with a catalyst will be broken, and that bond with reactant, that bond will be stronger than this bond with catalyst. Then for a short period, and if, for you can say temporary or for short period, or big bond will just they will stay there, just like a rented house, or just like in hotel for one night you are staying, like that way they will come, reactant will come, stay there, and both reactant will come closer, and after that bond, they will make a bond with catalyst, and after that they will make bond with the this reactant itself, and when they will bond, they will make bond, then slowly and slowly bond with catalyst will break, and you can say this bond between reactant will form. This bond will break, bond between reactant and catalyst will break, and new bond they will form with reactants itself. Then catalyst, actually this in the presence of catalyst many reaction takes place. Then here that in the presence of cobalt catalyst, carbon monoxide react with hydrogen gas and it form ethyl alcohol. Okay, CH3OH. Total 4 hydrogen was there. Hydrogen will be separate. H2 is there, then bond will break. Okay, bond will break. All 4 hydrogen will have separate one electron. Sometimes it will form H plus also, ionic ion H plus, but sometimes if this complete, you can say it will be in the atomic form H, H4H, each H has one electron. Then like that way it will form methyl alcohol, CH3OH. Methyl alcohol is liquid, it is alcohol, and this is the, here I am telling you, many people died, they have drunken the methyl alcohol. Methyl alcohol is a poisonous liquid. Ethyl alcohol is okay, it is a ethyl alcohol is non-poisonous in all type of wines. Ethyl alcohol is the main constituent. Ethyl alcohol, C2H5OH, up to 50% it will go, rest things will be other things, maybe fruit juice, okay, or water. Then here a spirit is also made from the ethyl alcohol. Then now I told you methyl alcohol, methanol, that is the poisonous. Keep in mind, poisonous. It is used only in industry. It is used only in industrial use, and you can say this in industries or in lab, sometimes methylated spirit is also supplied. Only so actually with ethyl alcohol, some methanol may also present. Okay. Then that is also called denatured alcohol. Okay. Other things they will add so that people can't drink it. Okay. But many people, illiterate people, they don't know, they will drink this type of alcohol and they will die. Actually, alcohol is not required in our body, not required. Why? Because already it forms in our body. When we eat rice or wheat, then what happens? This rice, that is actually, it will convert into the sucrose. It will convert into the, actually this rice and wheat, they have a starch. A starch is a big you can say big molecules, and that big molecules will convert into the sucrose, just like what we are using sugar in house, that is called sucrose, that is a smaller unit. All are just like you can say benzene unit only, complete starch benzene unit they will have. Then this is a very big unit. Then it will break into so many pieces in our body and it convert into the smaller unit. Then that I am telling you about the sucrose is the smaller unit, and this sucrose in presence of suitable catalyst, biological catalyst, that will convert into glucose and fructose. Okay, it will convert into the glucose and fructose. Again, glucose or fructose in presence of some suitable catalyst, it converts into ethyl alcohol plus carbon dioxide. Then that carbon dioxide we are releasing. We release carbon dioxide, that is that carbon dioxide, and ethyl alcohol is also produced. Glucose or fructose, it will react in presence of suitable catalyst, and that is also called enzyme, and it forms ethyl alcohol plus carbon dioxide plus heat. Due to that heat, our body will be always warm, and CO2 we are releasing, and ethyl alcohol will be in our body. That's why actually this here you should know, carbon dioxide is also formed. Carbon dioxide is also formed when we eat, then carbohydrate. Starch gives carbohydrate. Carbohydrate is different type of carbohydrate like maltose, sucrose, glucose, fructose, many are there. Then this we are getting or you will get through the food, and we are taking oxygen from the outside. In presence of oxygen, actually this will react. Actually our body, our stomach is just like an oven. It starts burning just after the birth. Okay, and we want to continue this burning. Okay, and for that purpose, this our food is just a chemical fuel, just like a petrol. Petrol is a fuel for the bikes, motorcycle, car, or other four-wheelers. Like that way, our food is fuel for us, biological fuel you can tell. Then you have to put fire, it should burn continuously. Or this stove or oven should should burn, means up to the last breath. Up to the last breath it should actually continue burning. Then that's why burning of food means carbohydrate, that is called combustion. Then this carbohydrate plus you can say oxygen. You know that for the burning anything oxygen is required. That's why we take oxygen from the outside. Then this oxygen will react. This oxygen will react with our food. Food means here starch you can tell, or carbohydrate you can tell. And that time it will also produce three things it will produce. First you can tell carbon dioxide it will produce. Second thing, water will be produced, water vapor it will produce. Third things, heat will be produced. Then this heat will be in our body, and carbon dioxide we are releasing. Okay, carbon dioxide in our body is forming during many reactions. Inside our body many reactions will be going on. Our life is fully chemical reaction only. Okay, then whenever you can say any sucrose, fructose, glucose will burn, it requires oxygen for burning, and it releases carbon dioxide plus water vapor plus heat. Then due to this heat our body will be always warm and carbon dioxides come out. Okay, then that is the main process. And second process I told you, glucose, fructose, when it will burn in the presence of some suitable catalyst, it will give these things. It will give ethyl alcohol and heat. That's why from the outside ethyl alcohol is not required. Here only you should know that we are taking oxygen. We want oxygen in more quantity, so that in our body whatever food we have eaten is starch we have eaten in the form of rice or wheat, that should burn. That combustion process will be going on. It requires more oxygen. If due to any reason less oxygen is reaching in our body, then what will happen? It will not burn. It will burn partially. It will burn, and in the place of carbon dioxide it will form carbon monoxide. CO. Then CO2 will not form, carbon monoxide will form, and carbon monoxide, it is a deadly poisonous. In the absence of oxygen or less oxygen, if more oxygen is not there, less oxygen is there, then we can die. Because carbon monoxide will form, and generally in our body blood is there. Then they have, you can say, 25,000 times more affinity for carbon monoxide than oxygen. In normal cases, they take oxygen. This hemoglobin, they will absorb oxygen and it will circulate entire body, because every parts of the body they require oxygen. But now if oxygen is not there, in the place of oxygen now carbon monoxide is forming, then this hemoglobin has you can say affinity for carbon monoxide 25,000 times more than oxygen. Even both are present, then they will take carbon monoxide and it will form, you can say, iron hexacarbonyl. It will form, and it will, in the place of oxygen, this CO will be circulated in entire body, and due to lack of oxygen that person can die. Okay, carbon in the place of oxygen, now carbon monoxide they are getting. Then what will happen? Carbon monoxide is deadly poisonous, hence person will die. Okay, very important things I have told you. Hence we should there should be no obstacle in passing the oxygen to the body. Freely it should go to the body in more quantity. Okay, now I am telling you another use. Okay, another use of hydrogen. It is widely used for the manufacture of metal hydride. Already I have discussed metal hydride. Now next application of hydrogen is, it is used for the preparation of hydrogen chloride, a highly useful chemicals. HCl, in lab we are using HCl. HCl is a gas, but when this gas will dissolve in water at high pressure, it forms HCl acid, hydrochloric acid. When it is dissolved, then it is called hydrochloric acid, otherwise it is called hydrogen chloride gas. Next application I am telling you, in the metallurgical process. In metallurgical process it is used to reduce heavy metal oxides to metal. Already I told you metal oxide will be converted to the pure metal. Then in industry we are manufacturing metal, iron or any other metal, then you want pure metal. Before converting to pure metal, it will be in the form of metal oxide. Then you want pure metal, only M. Then that time this hydrogen is used. It is used to reduce heavy metal oxides to metals. Okay. Next application, atomic hydrogens and oxyhydrogen torches. Now again you listen, this is again very important. application. Atomic hydrogen and oxyhydrogen torches find use for cutting and welding purposes. Okay, gas welding, you might have heard the name. If your bicycles breaks, cracks, or something, any metal items cracks or breaks, then you are going for the welding purpose. Welding, WELDING, welding purpose. Generally, I have seen, and I have once, and when my childhood, I have used this cycle. This was in cycle that crack had come. Then they have joined it by the welding, and in these things, garage. In garage also they will use these things, welding. Then there it is used atomic hydrogen and oxyhydrogen torches. Okay, that is used in the welding purposes. Atomic hydrogen these things, atoms produced by, how it functions, that I am telling you. Atomic hydrogen atoms produced by dissociation of H2 with the help of electric arc. Electric arc, that will be, by the use of electric arc, HH bond will be broken and are allowed to recombine on the surface to be welded. Surface to be welded. Suppose cycle rod is broken, then there that atomic hydrogen will be given. Okay, and there this, when it will go, actually that's why you see two things they will use. One torch they will use, that is the oxyhydrogen torch, and one rod will be there that will produce hydrogen bond will break, and when it will break, then it will release a huge amount of energy. It will release huge amount of energy. Then here important thing is that atomic hydrogen atoms produced by dissociation of H2 with hydrogen, HH atom is going to be produced by dissociation of dihydrogen with the help of an electric arc, are allowed to recombine on the surface to be welded to generate the temperature of around 4000 Kelvin, very high temperature, 4000 Kelvin. Okay, because when it bond will, its bond energy is very high, and it will form, then it will release very, because for to join this type to H, it will join, then that time this type 4000 Kelvin temperature was required. Hence when it will break, it will release that type of distance temperature, and welding can be done. Okay, next application is, it is used as a rocket fuel to space research. There rocket, it is going in a space. Then see the power of chemistry. How it is helping. Hydrogen fuel for rocket. If hydrogen is not there, then hydrogen is functioning as a fuel, then rocket will not go in the space. All you can say satellite, this propellant, what you are telling, for satellite, plane, and rocket, I know especially for the rocket, you can say this hydrogen is used as a fuel. Now fuel cells, hydrogen fuel cells also nowadays it is going to be used. There hydrogen gas will be used. Then see the value of hydrogen in a research space. Rocket is going, then there it is used. Or many, you can say, all fuels are chemical fuel only. Either you take any fuel, petrol you can take, that is the main petrol, diesel, kerosene, all are the fuels. Many fuels are there. then as per requirement they are using. Then hydrogen is used as a rocket fuel in space research. And one more application is there. Dihydrogen is used in fuel cells. Already I told you, fuel cells for generating electrical energy. See, means chemical energy is converting into electrical energy. Actually, here you should know, our food is also chemical energy. Our food, what we are taking, that is the chemical energy. Our food, fruits, what you are eating, all are the chemical energy. It looks like that it is the plant, leaf. How it is that they are in a natural way, they are a chemical energy. And that chemical energy, actually, due to the chemical energy, electrical energy is produced. Example, now I am telling you, dihydrogen is used in a fuel cells, okay, which is a chemical energy. Hydrogen, H2 is producing energy. Energy was hidden in a hydrogen. Now it is giving out. Then dihydrogen is used in a fuel cells for generating electrical energy. It has electrical energy, you can know. By electrical energy, now all over the world, whatever you are seeing, all type of vehicles, all type of vehicles, two-wheeler, four-wheelers, even the electrical engine, you can see, railway engines, everywhere lighting is there. That is due to the electrical energy. Battery you can tell. Then you can see the role of chemical energy. Chemical energy is converted into electrical, and electrical energy, now what they are doing, all the things. Everywhere electrical energy is required. Even in the all army of world. In the world, many countries has army, then all require their arms depends upon the battery. Battery, they are producing electrical, okay, energy there. Hence you can understand the value of chemical energy. Okay. Then dihydrogen, I told you, dihydrogen is used as a fuel cells for generating electrical energy. It has many advantage over the conventional fossil fuels. Fossil fuels means biological, burning wood and other things. And electric power. In the beginning, now hydrogen fuel is in demand. Okay, it does not, what is the main things of hydrogen fuel? It does not produce any pollution. Question is asked, okay, in competition. This hydrogen fuel is very important and in demand because it does not produce any pollution and it gives very high energy. That also It does not produce any pollution and release greater energy per unit mass of the fuel in comparison to the gasoline and other fuels. Okay, this I have discussed application, or you can tell usage of hydrogen. Okay, now I am stopping only here. Next class again we will meet. Thank you.